Okay, problem number 1. Find the midpoint of the line segment. So here's the endpoints of the line segment. In order to find the midpoint, you need to know the equation. Remember, that's going to be the sum of the x's divided by 2 and the sum of the y's divided by 2. The midpoint is a point, so make sure that you put it in parentheses and separated by a comma. So for our particular set of points, the x's are 19 and 5. You add them, divide by 2. And the y's are negative 10 and 29. You add them and divide by 2. And now you just simplify. So that's going to reduce to 24 divided by 2, or 12. And this is 19 divided by 2, which doesn't reduce anymore. And that's the midpoint. Number 2, find the slope. To find the slope, you need to know the slope formula. So the slope formula is change in y over change in x. So that would be y2 minus y1 over x2 minus x1. So remember, this is x1, y1, x2, y2. Okay, so it's just a matter of substituting in. So y2 is 23 minus y1 is negative 18 over x2 is negative 2 minus 13, which is x1. Do the math, and that simplifies to 41 over negative 15. If you can reduce this, you do. In this case, you can't. That's the answer. Leave it in fraction form. Number 3, we want to graph using the x and y intercepts. So first thing we have to do is find the x-intercept. Well, that happens when y is 0, so the y term goes away, and you get 8x equals negative 24. Solve by dividing by 8. You get x is negative 3, which means your x-intercept is the point negative 3, 0. We now need to find the y-intercept. Well, the y-intercept is found when the x value is 0, so the x term goes away, and you get negative 3y equals negative 24. Divide by negative 3, and y is positive 8. So the y-intercept is 0, 8. Now those are the x and y intercepts, and every line only requires 2 points. I'd like you to find a third point, any point, to find that as a checkpoint. I'll use x is 1. So I'm going to replace x is 1 in that equation. So I get 8 times 1 minus 3y equals negative 24. Well, 8 times 1 is 8, so subtract 8 from both sides. Negative 3y equals negative 32. Divide by negative 3, and y is going to be positive. It's about 10.6 repeating. Okay, so now that point you're going to graph is 1, 10.6 repeating. So now I will provide a graph on the test for you, but here we're going to just graph negative 3 on the x, positive 8 on the y, and then 1 and 10.6. So you see those do line up, and whoops, try to hit the dots on your test. Okay, so that would be your line. Don't forget that you want to go ahead and put arrows on the ends to make that an actual line. Okay, problem number 4, you want to graph using a table of values. First thing you want to do is make sure your equation is y equals, which it is. Put it in your calculator in y equals, and then go to the table. Remember, to go to the table, that means to hit second, graph. Find any 3 points in the table. Choose points that are between negative 10 and positive 10, and it'd be better if you choose points that are whole numbers. So I'm going to choose 0, negative 3, 4, negative 8, and negative 4, positive 2. Those aren't the only points you could choose, but those are the 3 I will pick. And then I'm going to graph them. So there's 0, negative 3, 4, negative 8. It's about there. And then negative 4, 2 is here. And connect the dots, put arrows on the ends, and you've graphed using a table. Okay, number 5 and number 6, we're going to graph using the slope and y-intercept. So problem number 5 is already in slope-intercept form. Remember, that's y equals mx plus b. So here the slope is 4 and the intercept is negative 3. Since I'm graphing, I want the slope to be in fraction form, and the point, the b to be in point form. So now we graph this. I'm going to begin at the point 0, -3, and then I'm going to move according to the slope. Since it's positive, I'm going to move up 4, 1, 2, 3, 4, right 1, and then do it again, 1, 2, 3, 4, right 1, connect the dots, arrows on the ends. Okay, before you can start this problem, you have to solve it for y. So I'm going to subtract the 4y from the other side, and then divide everything by -4. And y equals -1/12 x plus 15/4. So my slope is -1/12, and my intercept is 15/4. The slope is in fraction form, and the intercept is the point 0, and 15/4 we know is almost 4. It's 3.75. So I'm going to plot the point 3.75, almost 4, and then I'm going to move down 1 and right 12. And since I don't have any more room, I'm just going to leave it that way, but you could also, on this side, then instead of going down and right, you could go up and left 12. Okay, and so there's my 3 points. Connect the dots, arrows on the ends. Okay, number 7 and 8, you're supposed to tell whether the lines are parallel, perpendicular, or neither. In order to do that, you need to have a comparison of their slopes. So the first thing I need to do is solve this first equation for y. So I'm going to subtract x from both sides, divide everything by 5. So y equals -1/5 x plus 2/5. So my slope is -1/5, and my intercept is 2/5 for that first line. The second line is already solved for y, so that slope is 5, and the intercept is 1. So now when we make a comparison of the slopes, you see that they are negative reciprocals of each other. When slopes are negative reciprocals of each other, they are perpendicular. So you can either write the word perpendicular, or you can use the sign, which is that upside down capital T. Okay, with number 8, we're still telling whether the lines are parallel, perpendicular, or neither. Second equation is already solved for y, so we have a slope of 6/5 and an intercept of 8. This first equation is not solved for y, so we'll want to add 6x to both sides. And then divide everything by 5. And y equals 6/5 x plus 6. The slope here is 6/5 and the intercept is 6. Now we can compare their slopes, and you see they're the same. So since they're the same, they could be parallel. We now need to just verify that the intercepts are different so that they are indeed different lines. They are, and the slopes are the same, so these are parallel lines.